Hi everyone, this is Cloud Dragon Podcast, and today I'm going to talk on how to leverage SQL for making your application cost effective. And what I mean by that, I mean spending less time on application development in general and making sure that business as it is spends as little amount of money on their development efforts at all, because you could use that money to help business in other areas like marketing, production, etc. You don't want to invest like your 80% of the budget onto development costs, even if you're an IT business. In previous episodes, I covered that the majority of the costs associated with application are actually human costs, the salary development costs. And the reason for that is if you develop a project, as the time goes by, you have to pay salary and so on. And the major contributor to the cost is a project timeline. And all the human costs associated with running projects for years before you actually go to market. And if you dig into these costs, like development costs or some hardware costs, you would realize that they are not actually development or hardware costs. It's not something you have to actually do to give the customers what they want. Most of the stuff is just freaking out about some future problems that might possibly appear, like server failures, hardware failures, some issues, some corner cases, stuff like that. And all this freaking out makes your project timeline to shift considerably further into the future. I'm not talking about we will have a deadline shifted for 1 month. I'm talking about like a years of shifted deadlines, like month after month after month, because developers come up with new ways to show how smart they are, and to show, we need to handle this corner case, and you can't release the software like later and later and later, and you always get an answer like, we need to solve this, and a lot of buzzwords like Kubernetes, high availability, whatever, instead of actually going and delivering you what you want. And if you make an analysis in terms of the business, I've never heard that some company didn't succeed because they had a crappy product in terms of it was like not reliable. There are some cases, of course, like when your product is really not reliable, for example, you have an API that doesn't work like every month. In that case, your product is crap and you wouldn't have customers, but you wouldn't believe I saw such companies and they still work, they still survive because the marketing and business works pretty good. So the thing is that you probably want to concentrate on the business side of it, not the development side of it. And if you go into the development side of it, all the possible problems that developer want to solve, you will soon find that the major source of the problems that developers are trying to solve are actually developers themselves. It's a human error, it's a security issues, it's some bugs, it's some releases that they did incorrectly, like they changed something and now it's just not going well. So the major contributor to the uptime, to actually reliability of your application, is human error. People are making mistakes, and they don't do mistakes because they are stupid. I don't believe that. I believe that people do mistakes because the system that they're working in is too complex for them to handle. When the system is really complex, you will inevitably have human errors, because you might fire one developer and hire another one, but it's not going to solve a problem, because if your system is complex, any developer is going to make a mistake. It's just not possible not to make mistakes in your system. And if your system is simple and it's clear, then it's very hard to make a mistake because you will see it earlier, it's easy to remediate if it's making, and it's even easier to test it before releasing it. So everything is more reliable in a less complex system. I've already covered the complexity in previous episodes about how to create simple applications, and I've covered how you could simplify everything by using API tests and so on. But in this episode, I wanted to concentrate on how SQL, with its guarantees, with its history and simplicity, could contribute to making your application development faster, cheaper, and more reliable. Actually, it's not just about the cost. By the way, I also don't like the reputation that SQL started to receive recently, that it's some old technology, or it have like everyone for some reason remembers the services that have like thousands of tables and how some monoliths, some unmanageable databases, etc., etc. And so there is a lot of scary things related to having just one database that just sits on one server, and everyone talks about that. I don't like it. I think it's just some fear mongering. You have these issues. But if you go to reality, I already show you that the major problem with applications is humans and not SQL or technology you use. And if you go on the internet, you will soon find that NoSQL is not that popular actually. MongoDB is quite popular today because of its kind of simplicity, just set it up and so on. But if you talk about alternatives, I see kind of NoSQL have like zero visibility on the search. I don't know why. And if you go into the comparison of Postgres versus MongoDB, you could actually see that Postgres became more popular after MongoDB release. Actually, you could see that the red line is pushing this blue line up. And you could see that the Postgres actually on its popularity trend, it's getting more and more popular than MongoDB. No wonder. I see this represented on Stack Overflow service, and I hear the same stuff from colleagues that people are getting tired that many things that you could do in SQL you can't do in NoSQL, and you have to struggle for weeks or months to come over this problem that you could have solved in SQL with just one query. And no wonder that Postgres gets more popular, because it actually combined the benefits of this NoSQL trend with an old SQL world. Because today I could have just few tables, and they have a JSON inside that I could index, I could query on. And I no longer have these hundreds of tables in SQL that I have to join and wrap my head around. Like, I could have like 5 or 6 tables in my service, like the most important business entities, and I could join them and however I want. But all this data that is related to specifically one table here, like one-to-many relations or one-to-one relation here, I could just don't worry about this. I could just store it in a JSON and retrieve it. I no longer need to do all the joins to get this JSON. I could just get it. So it makes everything much, much more simpler. And again, as I say, simplicity means reliability. It means cost effectiveness. It means everything. It means everything is better if the system is simple. And this method allows it to be simple. Because if I take MongoDB and I try to store stuff in MongoDB like this, it's going to work, but I cannot do joins. I have to struggle to make joins working correctly, and I have to struggle to make atomic inserts work on NoSQL too. Like if I want to update 4 or 5 tables or collections at the same time, in NoSQL I have to come up with some crazy architecture with event sourcing or CQRS or whatever to make things actually work in a consistent manner. But with SQL I could just do a single write. And with Postgres I could even do the single write to the multiple databases in one round trip. Like it's crazy how effective the SQL world became. Like you could just make one request and you get an atomic update into 5 tables. It's incredible. Like I could now have a database sitting like in a different country on a cheap server, and I still have good latencies for my service because I no longer have to create a transaction, get this, get that, get that, get that, get that, and then make an update, make another update, make another update, and commit. Now I could send one query to return a join of multiple tables in a JSON format, create an update that updates like 5 tables in a row. So I could make this complexity happen, and I don't have to make it happen on the database, because on a database it's simpler. I could just craft an SQL query, and it's not that complex compared to all the crazy JSONs with all these 100 tables, because I just need to update 5 tables. I don't need to update everything. Another benefit of SQL is that I could control concurrency. With NoSQL, I have no way to control concurrency, making sure that one synchronous operation is done after another. For example, I have 10 API calls coming on my service and I want to execute them sequentially. With NoSQL, it's really hard to do because I have to do optimistic concurrency or similar stuff, or I have to use queues or other craziness, and then I have to, when the service actually makes an operation, it needs to make sure that it actually was performed. So any architecture is going to be, let's say, complex. But with SQL, it's very simple. Like you just have select for update for some users table, for example, and make sure that all operations for the users are executed sequentially. And this locking problem is solved for me pretty easily. Not even saying that it's more effective to do that manual locking yourself, because you could control, you could avoid this problem of dirty writes in terms of, I have a conflict and I have to retry the transaction, or I would have a read, or I will have a write that is stale or something like that. You could actually, just execute all these transactions sequentially, and you kind of don't care about this anymore. It makes everything so much easier, because with this one, with this approach, all operations on my API could be synchronous. Like it's not like I receive an operation, then I do something in the background, and then I give you a callback. If I could do everything just in in half a second, I will do everything and I will return you a result immediately. It makes the whole design of API much simpler and synchronous, rather than do this all asynchronous stuff and all the queues, callbacks, webhooks, whatever, and it makes everything sad. So this AC semantics, they allow you to just build a simple service that receives a request, processes it, and gives you a response immediately. And of course, with Postgres and MySQL, for example, you could implement a lot of patterns, a lot of use cases on it that typically would require, in NoSQL would require some other databases, or would require some, specific functionality or stuff like that. So you could do a queue on the Postgres. You don't need to use a separate service for that. You could do the caching. You could, in MySQL, you could create a memory table. In Postgres, you could create unlock table, this table is kind of more performance than a typical table, and you could use it for cache, for example. You could do some basic search on the database if you don't need like very, if you don't have like terabytes of data you have to search, and maybe some library for Postgres that does a search is going to work for you, and you would not need a separate dependency. Not even saying that if you have a powerful server, you could just scan the whole database pretty fast. Like if you have just few gigabytes of data and you have a powerful server, like I showed before, you could just do sequential search and it's just going to work, and you could get away with that. All the locking, you can even use database as S3 storage, because you could create a database, separate database, and put the data not on SSD storage, but on some cheap hardware, some cheap HDDs, and it's going to work the same. You could actually use the database as a storage for some big files, uploads, or anything else. It's still going to work. And again, for example, Postgres has a notification mechanism that you could use to synchronize your services too. Like a lot of use cases that in today's microservice Kubernetes world would require you setting a different container, service, or whatever, in practical terms could be solved just by using one Postgres instance. And if you worry that, it's not going to be performant because it's one database, you're actually falling into this trap of premature optimization. You don't need to think about this at all. Like, unless you're really 100% sure that it's going to be working slow, then you could address the problem prematurely. But in most cases, you just want to create an applications that customer wants, and you could just get it going, get some customers, get some load in your production, and then see how the system performs. And as your customer base increases slowly, then you have a time to actually fix the bottlenecks, address scalability problems, and so on and so on. And if you have customers and if you have cheap hardware, you could actually scale up for quite a while before you would be forced to actually change your architecture. Most optimizations are actually pretty simple, like adding an index or putting the data in a separate table, something like that. So this solving of performance problems is, you don't have to do it right away. If you manage the database yourself and you manage it on some cheap server, like this is an example server from Hetzner, you could get incredibly cheap pricing for that. Like, for example, if you use Hetzner and you manage the database on a dedicated server yourself, you have like 80 cores of performance, 256 gigabytes of RAM, and 4 terabytes of NVMe storage for $20 a month. Or if you use a managed service on AWS, you would pay more for a simple instance with 4 CPUs and 16 gigabytes of RAM. And I'm not even counting this 4 terabytes of storage here, because the 4 terabytes of storage are going to cost you like, 4 terabytes multiplied by 80. It's going to cost you like $300 more on the AWS. Like it's crazy how this, managing your own database and huge powerful server is much cheaper than sit and worry about all of these, costs on the cloud. Like imagine you have to hire developers. You could hire a senior developer who would be able to create cost-efficient applications that could run here, or you could hire a person who will charge you $200 less, but this person would have a database with like 80 cores and 4 terabytes of space. Of course, he would, he would have much more leeway for error than this person has. I'm not telling that you should hire dumb people, but the point is here that the developer time is extremely expensive, and you just want to throw hardware as a problem. And managing database today is not hard. You just do it once and it's working. Having this managed service makes only sense if you have a lot of databases and you can't sustain them. And if you're worried about the durability, like, oh, what if database disk fails or something like that, if you have a dedicated server with 2 hard drives, it's a very reliable setup. Most probably you will screw up some configuration on a server or run some query that deletes everything, rather than you would have a server failing with 2 hard drives at the same time. You need to actually make sure that your hard drives are replaced in time. For example, for Hetzner, you should actually monitor your email so that you will see the email that your hard drive has failed, and you have to ask support to fix it within 1 day or or a few hours, let's say. And if you don't do that, well, now you're running on 1 hard drive, and if that fails, then you have a problem. So if you have a database and you replace hard drives in time, when they fail, you have a very reliable setup. And all this, high availability in terms of having multiple servers and stuff like that, it actually doesn't make system more reliable, because if you have 2 servers, now you have to make sure to configure the master and the slave correctly, and if you don't do that, you could screw up your data. You have to configure replication. there is a lot of stuff you have to configure to make this reliable, and there is no guarantee that it's going to be reliable, because you have 2 servers. Now there is a 2 times more chance that they will fail, and now everything is more complex, which means everything is more expensive for you, and there is more chance for you to screw up something. But if you have just 1 server and you just do backups, preferably off-site backups, because sometimes the data center could be on fire, and both your disks could die, could die burning like a flame. So what you want to have is off-site backups. Sometimes there are problems with hosting, stuff like that. Everything would happen. It's very rare, but still could happen. So having a replica in the same hosting doesn't help you, because again, it's the same data center, so there is no point to having that. And if you have replica in some other country, then, well, your writes are going to be slower, and now you have to support both data centers, and it's not clear what benefits you would actually get compared to saving this money and just paying out them to customers if you have a downtime. Like, imagine you're having a Facebook account, and every time Facebook is down, they pay you. It's a dream for every customer. So it's not clear that actually solving these problems would give customers a benefit, because they probably want to see cheaper prices and more features, instead of making sure that your service is uptime 100% of the time. Because, for example, if Facebook is down, I don't care. If YouTube is down, I don't care. If Google Calendar is down, okay, great, I will have more free time. Like, the services that are really critical and really you need to make sure that they are up and running, they're not so much. Like, I don't know, military applications, medical applications, I don't know, maybe some financial markets that are really critical, because if you're down, you have like a lot of losses associated with you. But for 99.9 businesses, okay, it's okay to be down as long as you're good at business and you have cheap prices and you give customers what they want. They are okay to wait for a few hours for you to run the server in a different on a different server. They have no problems with that. They kind of understand that this happens because you already will earn their sympathy by providing a great and cheap service. So wrapping this up, if you're like thinking which database you should just choose SQL by default. It's not the silver bullet, but it's a very good place to start, because it kind of solves most of the problems that are occurring, and if you have a problem that SQL doesn't solve, then you could migrate to another solution. So by default, you just want to have one database for all your applications, and all of them just work with it. You don't have this zoo of different services like Kafka, MongoDB, Redis, blah, 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 S3, whatever. When you have so much services kind of configured, then the whole system is more complex, it's harder to test, and so on and so on. So it all increases complexity. But SQL, because it kind of puts everything in one bucket, it makes everything simple. And you probably want to concentrate on simplicity first rather than concentrate on some future problems that the developers typically freak out about. And one important thing about all these downtimes and performance issues, etc., is that if you want to develop a new product, imagine I develop a product in 1 month and you develop a product in 1 year. Well, your product compared to my product was down 11 months. And it was not available 11 months, and it has 0 performance in 11 months. So having a service earlier and running business on it is much, much better, even though it's going to be not performant or it's have some problems. It's much better than just making an ideal service in 1 year and then slowly ramp up the customer base. So you want to have a business features first and optimizations and risk management later. That's all that I wanted to discuss in this episode. Hope it was interesting and valuable for you. See you in your future episodes. Bye.